Hey everyone, thanks for joining. We're just going to wait a few more minutes for some more attendees to come on in and then we'll get started. So thank you everyone. All right, I think we can go ahead and get started. Hi everyone, my name is Sedona Ryan. I'm the Research Project Coordinator here at UNC Institute for the Environment and for the CMAS Center. So I want to thank you all first for joining us for the next installment of our webinar series. It's really great to see everyone joining the meeting. A few logistics is throughout the presentation, you can post questions at any time using the Q&A feature, which you'll see at the bottom of your Zoom. I'll be here on the back end kind of answering any troubleshooting or Zoom type of questions as you have them, but then otherwise we'll save all of those questions submitted to the Q&A until the end of the talk, where we'll discuss that and any other technical elements. Also, at that time during the Q&A, you can raise your hand, and this will send us a request to unmute you if you have something else you want to discuss, or maybe a longer Q&A type of question, then we'll handle that there. We also ask that you remove or deactivate any AI note-taking or related tools like that. Those are not permitted during our webinars, so please take a moment to turn those off now if that's something you're using. And with that, I'll introduce Dr. Saurav Arunachalam, who will be introducing today's speaker. So, Saurav?
Thank you, Sarana. Good afternoon, good morning, good evening to everybody who has joined today. I'm delighted to host the next session of the CMAS webinar series. You heard from Manish last time, talk about how we did port CMAQ for running production simulations on the cloud. Now, after we have run the model, it's time to evaluate. Some of you may know about the AMET tool that was released by the US EPA to the CMAS Center a few years ago. There have been incremental updates to AMET. But more importantly, what we have is, in the spirit of moving a lot of the computing to the cloud, we have ported AMET, the latest version of AMET, to the web-based interface. And that's what you're going to be hearing from Liz. So with that, without taking further time, I'm going to introduce Liz Adams. A lot of you may know Liz Adams. She's been with UNC and CMAS Center for over 2 decades. She has a double master's, both from UNC, one in chemistry and one in the School of Public Health with the Environmental Sciences and Engineering. And she's been a very critical member of the CMAS team, supporting the community for the past 2+ decades in terms of getting CMAQ up and running and various other activities, including supporting the CMAS data warehouse. With that, let's turn it over to Liz.
Hi, all. Thank you very much, Saurav, and I'll go ahead and share my screen and get started. So I'm going to turn off my video, but I'll come back on at the end of the session. Thank you. Okay, so today, let me get the slideshow going. I'm pleased to discuss the cloud-based approach to an atmospheric model evaluation using AMET-Web, and I thank my co-authors, Manish and Saurav, for their help with this presentation, and also want to give recognition to the developers of AMET, Wyatt Apple, Rob Gilliam, and Christian Hogreff at US EPA. And if there's any errors or omissions, That's my responsibility. But hopefully the presentation will be clear and you'll have a good understanding of how you can get started using the AMET website. So the objectives are to describe the resources that are supported by the CMAS Center and the EPA, to introduce AMET, to demonstrate the AMET website on an AWS Cloud virtual machine. And on this virtual machine, the following data sets have already been installed: aqExample for CMAQ 12 US1, and then metExample for WRF, MCIP, and MPAS. And we also have a long-time series, the EQUATES, from the EQUATES project, so 18 years of CMAQ 532 model results that can be analyzed. So we'll also at the end be creating and visualizing air quality and meteorology model observation evaluation plots using the websites for AMET-AQ and for the MET-AQ, or for the AMET-MET website. So to describe the CMAS Center resources, we've been helping the EPA with their open source software for over 25 years. We have several products, more than 10, but the ones I'm highlighting here include AMET, Verity, Smoke, and CMAQ, and we do hope to have model releases out at the end of this year for each of these packages. So the cloud-based AMET-Web on AWS, AMET is a publicly available and open source software. I have a link here that you can go to learn more about it at the EPA website, and I also have the link for the paper by Apple et al. In 2011. It is itself built using open source software packages, including R, and it's dependent on MariaDB database software that's leveraged to store and query the paired observation and model outputs. AMET-1.6 contains PHP code that uses an Apache server for web-based model evaluation. And we created an AWS AMI that's pre-installed with AMET version 1.6 to facilitate the use of this AMET-Web by the CMAS user community. And we hope that you will use it. So the resources that we have that support AMET include the CMAS data warehouse, and that's where you get a lot of these really large model output data sets and the emissions data sets. So there's a link to the data warehouse. The metadata is also available on the UNC Dataverse. We have the CMAS Center user forum where you can go and ask questions following this webinar. If you have any questions about AMET-Web, I've included a link to the AMET section of the forum. And then we also have the conference coming up where you are invited to submit an abstract to the cloud computing session once you've done some great model evaluation using the AMET-Web. And what previous webinars included a webinar for AMET version 1.4, and I encourage you to go back and watch that as well if you would like to learn more about AMET, more detail from the model developers. We have a CMAQ and AMET on AWS Cloud tutorial, and which I'll be showing. And then we also have a help session the first Thursday of the month, of every month, from 3 to 4 p.m. that you can register for on Zoom. So next we have an introduction to AMET. So the general overview of AMET is that it does model evaluation for both MET and air quality models. For meteorology models, this current installation contains a database with WRF, MCIP, and MPAS model output. And for air quality, we have it for CMAQ. But you could also evaluate CAMX or even the coupled models, WRF CMAQ or MPAS CMAQ. AMET again uses open source software, including MariaDB. It requires post-processing your CMAQ output with AMET tools, which are also known as the CMAQ post-processing tools. And it uses our statistical software for the queries and analysis. The advantage of AMET, and this is pretty much a bullet list from the developers of AMET, is that it's capable of managing large data sets efficiently. It's a partially automated system. It has a relational database that allows for unique querying of data, and it has predefined analysis scripts in our programs. Users can also develop your own custom analysis or leverage output files to do your own analysis. So for just people who are new to air quality model evaluation, I wanted to go over why it's useful. So it's useful to help identify and confirm seasonal or hourly, daily, and seasonal pollution patterns. For pollutants with a short atmospheric lifetime, you can possibly learn some additional information about local and regional air quality information. For pollutants with a long atmospheric lifetime, that help, like CO, it would help provide information on long distance transport at synoptic scale. So like what's happening with the cold fronts, how does that impact pollution? And then for understanding the behavior of secondary pollutants, AMET helps to evaluate the components of PM 2.5 that's made up of both primarily emitted as well as secondary compounds that are formed in the atmosphere. So things that we can do with model evaluation are just ask questions. Are the models capturing both the minimum and the maximum values of ozone, PM, and other pollutants compared to observations? Lots of questions that can be asked doing model evaluation. And I have some references at the end of this talk that'll help you if you're interested in going into more detail. So we use AMET, or the EPA uses AMET to evaluate the impact of new model schemes. So when we do a release, these model releases are evaluated. And so any of new code model runs are done for certain scenarios to understand basically any changes that have been made. And this includes, let me move this down. This includes like doing a model evaluation after an improvement in emissions inventory. Emissions inventories are released every few years. And then also you could do a model evaluation after using a higher resolution emissions inventory, such as the 1 kilometer NEMO database that I believe will be made publicly available soon. So it's also used to evaluate long-term trends and evaluate improvements in the meteorology models. And these are some additional references. So it helps just to help orient you in understanding the data and how it gets loaded into AMET, so that the air quality observation data is prepared by AMET developers. So they download the data from each of the networks and make it available in a format that can be read by AMET. And so you have to download that data from the CMAS Center data warehouse if you were doing your own installation of AMET. And since we've already done this for you, you won't have to do that step, but it is important to know where the observation data is sourced from, and there are metadata associated. There are metadata available to describe these data sets as well. And for the most part, I think most of the networks or the sites available for observation data are located over the CONUS US. And so that's an important detail to know. There are some European sites and some other sites as well, but for at least this AMET installation, the data sets that we have are over our 12 kilometer resolution over the US for the air quality data. However, for the meteorology observation data, we do have a model, MPAS, which is a global model. And so that model can use METAR sites, observation sites that are available across the world. And so this is just an image of where those METAR sites are located, and they're primarily at airport locations across the world. And then the model output data, when you're doing these model observation paired loading into the database, you have to have both the observations for that species and the model data for that species. And so there are a lot more model data species that you could examine and evaluate than we have observational data for. And so that limits the number of species that can be loaded into the database. So we currently have 40 air quality species in EQUATES, which is that long-term 18-year project, or there's a lot more species in aqExample, but we don't have observations for each of those species, even though we have all of that model data. And additionally, so we have the number of model obs paired data is dependent on the horizontal resolution and geographic area of the model that you ran and the length of time that you ran the model for. And so all that factors into what data is able to be loaded into the MySQL database to be queried and then to make plots from. So it's important that you understand the model that's been loaded into AMET. And I have in the tutorial that I provide, I have some sample queries that you can do to see exactly what species are available, what networks are available. And so that kind of, I won't go into it in this presentation, but it's important to know that you might have to have some small knowledge of MySQL queries. So these are the domains that were loaded into AMET for the aqExample case. So the AMET database has a case called aqExample. Actually, no, this is for the temperature. This is for the MET side. So the, I think it's called metExample _ WRF, MCIP, and MPAS. And so these are the domains that are for those model outputs. So WRF covers just slightly bigger area than MCIP. MCIP is a subdomain of WRF, and then MPAS is a global model. And so you have model data that covers the globe. For aqExample and for the EQUATES simulation domains, I think they're identical as far as the domains, but there's a different length of time that we have data for. So aqExample is only for the month of July in 2018, whereas EQUATES, we have data for all of the years. So 2002 to 2019. These are just two plots that show the ozone variable in Verdi, just to give you an idea of the domains. For pairing model and observation data, you have to use the CMAQ post-processing tools, combine and site compare. And combine helps combine the model variables to create the species that make up PM 2.5 with the appropriate cutoff in size. And then because you need to be able to compare that to what's measured at the observation sites. So again, the model output data was obtained from the CMAS data warehouse. So if you're doing your own installation, you would have to go to the AWS or go to the AWS CMAS Center data warehouse and download the data. These are the two files, and they're 51 gigabytes and 39 gigabytes. And then for the month of, I think it's July 2016, we have metadata, and the size of that data is 787 gigabytes. Once site compare is run to process that model data and do the pairing with observations, the size of the MariaDB tables, which you can find under the MySQL directory, the EQUATES data, so all 18 years is 220 gigabytes, and the AMET database is only 3.8 gigabytes, just to give you an example of the different sizes of these databases based on the amount of data that they contain. So part of what site compare and combine are doing is data making sure that the data matches. The data from the model and the data from the observation stations are the same species, that they're in the same time zone, that they that we use. I think there's something going on behind the scenes about examining the quality control flags for the observed data to make sure that we're not using data that's faulty, and then making sure the units are uniform, making sure that the locations are correct after matching the model data to the location of the observation station, and then ensuring consistent averaging periods. Okay, so the number of plot programs that are available for AMET, these are programs that are already created to create plots, and there are many different types of plots and many variations of those types of plots, and those are listed in the parentheses for each type of plot. So for scatter plots, for instance, there are 14 different R programs that could make different types of scatter plots. Same thing with time series plots. There's 12 different programs that you could run through the AMET website to create different types of time series plots, and then spatial plots the same. And I kind of listed what these plots are trying to show. So when you come back to review this information, in this presentation, I'm primarily going to be demonstrating the time series plots and the spatial plots and the animated spatial plots. And the rest of the plots are described in the AMET section of the cloud on AWS user guide that I've prepared. So even though I won't cover all these types of plots in this webinar, they are documented, and they're also documented in the AMET documentation. So next we'll go into details about how to create an AMET website on AWS. I guess first we'll kind of describe the advantages of using it. So again, for cloud-based AMET, we're using the latest version of AMET that's found in the develop branch currently, but by the end of the year, it should be available in its own branch on GitHub. And so we use that branch, and we use all the libraries. Those are pre-installed on the AMI. So you'll get a copy of the AMI and then be able to launch an instance from that AMI and be able to use the website. This is a screenshot of the tutorial, and I'll try to demonstrate how to use that a little bit as well. So it's in Read the Docs, and it's fairly easy to navigate. It contains a lot of content, but hopefully it will help you if you're trying to create a plot and can't seem to get the plot to work. You can review the user documentation here and see what you might be doing that's causing an issue, or what AMET is doing that causes an issue to generate the plot. So again, this part has been done already, matching model with the observations and loading it into the Maria database. So the data all was preloaded for you. You can still use this AMET website virtual machine to load new projects. It would just require you to download the model or upload the model data that you would like to analyze, and then edit the database loading scripts and load the data into the database. So this AMET version again uses PHP GUI for analysis to create the interactive plots from the web browser using Apache Web Server. A benefit of AWS is that it's scalable. So you can create a virtual machine that is smaller than what I'm currently using or what I recommend using if you only wanted to examine the aqExample monthly data. And say you want to get rid of all the EQUATES data, you would need a machine that has a much smaller size in terms of compute requirements, and also because you wouldn't need as much memory, and also you wouldn't need as much volume storage. And so that's a nice thing about AWS, is that you can create a size machine based on what your needs are for running AMET-Web. You can also start and stop the virtual machine and or terminate it to reduce costs and save costs. So this is how you would create the EC2 instance from the AMI that we saved. And so these instructions I'm only going to kind of talk about in this webinar, but they'll be available for you in a PDF, and so you can follow these instructions. You go to the console after you've created an AWS account. You select the Northern Virginia region. This is where the AMI resides, and so you would this is assuming that you're going to create your virtual machine in the Northern Virginia region. If you need a different region, you first have to copy the AMI to the region of interest and then do these steps for that AMI that you've copied. And in that case, you would need to search for a different AMI in your region because you've copied it and their AMI has changed its identification. So you go to the Northern Virginia region, you select the public images tab. This is this tab here with next to number 2. Then you use the search box to search for the ID equals to the AMI name. Once it's searched and found it, you select it, and then you say launch instance from AMI. Once you've done that, selected launch instance, you're taken to this screen, which is requesting some more information from you. So you need to confirm again that you're in the correct region, that you've got the correct AMI. So this is the AMI image ID, and this is the name of the AMI. You select a T3 extra large instance type, and you create, I'm saying that you should create a new key pair, but because I like to keep key pairs for the types of applications that I run. So, but create a key pair, or if you have an existing key pair, you can use that. And then for network settings, we're going to go to the next slide. So in this tab under network settings, you'd need to create a new security group. And in this case, I'm recommending that you allow SSH traffic from your IP only. So only someone with your IP address would be able to log into this virtual machine. But we're going to allow HTTPS and HTTP traffic from the internet. And this is going to allow the website to work. Your organization may have different or more restrictive access policies for HTTPS and HTTP. And so probably before doing this step, I would check with your organization. But otherwise, if you can use access from the internet for the website, I think it's probably fairly secure. Anyway, and then next, once you've done that, selected the IP, let's see, there's another step. Oh, you go over here to launch instance, and number 2, then you would be presented with a new screen and it would say success, you've launched the instance, and then you would click here on this line and you would get details about that virtual machine. And so the details that you need to capture before you go to the next step include the public IP address and the private IP address. And you're going to need both of those to get the website running. I'm going to go to the next step. So here I'm covering the cost of the EC2 instance, again stressing that right now the AMI is 500 gigabytes of storage, which is enough for everything that we're doing. For me to set up the model data, doing the data loading. At some point, I think I'll be working on getting that AMI size volume down to a smaller size. But right now, that AMI cost is about $6 a day for both the virtual machine and the storage. If you turn the virtual machine off, you're only accruing storage costs. And that would be including the GP3 volume, and then the AMI was about $2 a day. If you only wanted to use the AMET database with the aqExample, metExample, the 1-month case, you could get the cost down to about $2 a day, so about a third of the cost, and the storage would be minuscule. So the storage cost alone would be about 13 cents. Okay, for deploying the website, now you would need to log in using the key pair that you created using SSH into the public IP address that you had saved in the previous step. So we're going to log in, and then we have to edit the ports config file for Apache. And in that file, this /etc Apache2 ports config file, you need to specify the private IP address. So I had you save 2 separate IP addresses from the virtual machine. And then once you've used the private IP address in the ports config file, you'll need to restart Apache and restart the Maria database, and then log out of super user. And then once you have that working, you'll create the air quality plots using the AMET-AQ website using this HTTP your public IP address :/443 port 443, and then querygen aq.php. And this is what it looks like. So if this is successful, you're golden. If not, you'll have to post a question in the user forum or come to the cloud help sessions, and I'll try to work with you to find what the issue is. But this indicates success, and then later on I'll show you how to use the AMET database to create the plots. So this is a navigation of the AMET website. I kind of just created snapshots of what you need to focus on, and those include choosing a database, choosing a project, selecting a region, selecting the observation network, selecting the species, selecting the time range. So here I usually change the month to July, so that the plot titles have the correct date range in them. And then I select the program to run. In this case, we're gonna, it was the multi-species time series plot. So one of the time series plots, and we have selected 2 species, and so that's why we're using the plot type that allows 2 species to be used in creation of the plot. And then you click on Run Programs. Once you do that, you'll get a result. So in another screen, you'll see this description of the MySQL query. So the query was get the station ID and obs dates and model data and create the plot. And then you would click on one of these plots to view the plot. Behind the scenes, what AMET website is doing, the querygen aq php is located under the cache AMET directory, and when you run that PHP query, run program, it saves all the settings information to your runinfo.r, and then it saves the requested program name to the runscript.csh. Actually, it saves it to the runinfo.r as well. So in the runinfo.r, the program name is specified, and each of these programs has a description at the top. It has the instructions for how to query the database. It has instructions on how to save the data to a data frame in R, and then do the averaging, writing the data to a CSV file. So that this is an important detail. If you want to create your own plots using R or Python, this paired model data is saved to a CSV file that you can use with your plotting programs. But this is an important detail. You can use AMET and not do the evaluation through the website and use just the paired model obs data, but you would have to make sure that you understand what the query was that generated that data. So after the program completes, the plots are saved to the cache directory and displayed on the website like this. And then if not, you would get an error message here, and it would display what the error is and why. And you have to read that error message to diagnose why the plot failed. So this is an example of an AMET multi-species time series plot, the one that we just created. So we have NO and ozone. And so I think this is ozone and this is NO. And then this is the bias, a bias plot for those species as well. And this was on the website, this is what that selection to choose that particular program. And this plot takes about 1 minute to create. So think it's a query for 2 species for 1 month. The next plot is the AMET Plotly multi-species time series plot. And here I'm showing, this is an interactive plot where you can disable some of the data. So we also created it for NO and ozone, but I've turned off ozone so that we can only focus on looking at the time series data for NO. And so you can see the model observations are high, or the observations are higher than the model. And so there is a bias in, let's see, that's not right. Yeah. So this is the model. So there's a bias that between the model and the observation data. We don't have the bias down here, but this plot can allow you to kind of zoom in and look at only a day's worth of data. And so that's what the interaction is, in addition to turning on and off these traces. But you also, if you had longer data sets, this is only a 1 month set of data, but if you had longer, like a full year's of data, you could also do subsetting up here in the upper left corner. So this plot takes about 2 minutes to create, and the query is again for 2 species for 1 month. These links here would allow you in the next few days to look at these plots and interact with them using the IP address that I'm currently running for the AMET website. But if you, I just wanted you to see what the link looks like. If you create your own AMET website after you've copied the AMI and created a virtual machine, you would want to replace this IP address with your IP address for your virtual machine. And otherwise, you can look at the same plot. The next plot demonstration is of the Plotly multi-simulation time series plot. So here we are showing model and OBS. The OBS are in black, and the model are colored for each year. So EQUATES has 18 years of ozone data. And so we're looking at basically in the winter, the ozone values are low, and in the summer, the values are higher. This again is over the whole 12-kilometer CONUS domain. It's an average of the model data in comparison to the observation data over that same domain. And so this plot at the bottom shows the model bias, and I tried to draw a line here which kind of shows when the model bias is negative. This is showing that the observations are higher than the model is predicting. And so there's a negative bias. Over here at 2009 is an example where the model values are higher and the observation data points are lower. And so that's a positive model bias. This Plotly multi-simulation time series plot takes about 5 minutes to create. And again, this query is for 1 species for 18 years. So that's an example. You can do things with this interactive plot like zoom in to a specific year, or so I did both. I zoomed in, but you could also turn off these traces and only look at one, but you would still need to zoom in to see kind of more detail. So this is showing ozone is lower in the winter and increasing in the summer and being lower again in the winter. Sorry. And when you're using the interactive plot, you can click on each plot, each point, and see what the value is. So the advantage of the EQUATES data set is you can kind of see these seasonal patterns that you can't see with just a 1-month simulation that's in the aqExample case that's typically provided with AMET. So I'm kind of excited about being able to look at these 18 years of data through this AMET website. The next plot example I'm going to give you is for PM25 total over the 12 US1 domain for EQUATES again. So this plot takes a lot longer. It takes 43 minutes to create, and I'm not exactly sure why, but I just wanted to make a note of that. So once it's made, again, you could go back and visit this plot at any point. So this plot should exist on the AMI, and you can just use your IP address, or for a few days, we're offering folks to just look at using the IP address that we have currently running, but you can interact with this plot using this link down here. So again, this, I didn't really talk about the previous trend, but it was in the slide. The trend for PM 2.5 and for ozone is over time from 2002 to 2019 that the values of ozone are decreasing due to emission controls in the United States. And so the next type of plot that I want to introduce is a spatial plot that shows some of the statistics values. And so this plot, again, is interactive. And in this case, I've just selected the correlation statistic. And so when the correlation is 1, you have good agreement between the model and the observed data. And so this is showing perhaps something of interest in that the model correlation does not seem to be very high in the center of the country, but it's very good on the east and west coast, although there may be some poorly correlated sites hidden under these good, very large bubbles. So this would take some additional exploration as well. So you could look at the normalized mean bias, normalized mean error, all of these different statistics, and help you evaluate the model performance. This is another plot, that same type of plot, showing the correlation for ozone 8-hour max. I think the other one was for PM. So this shows a little difference in that the poorly correlated sites seem to be over Colorado, New Mexico, Arizona. Good correlation here, maybe not so great correlation in the mountains. And so it could be that there's like a topography issue, like the sites that are located on the mountains aren't agreeing as well with the model results. This is all great questions for research. So, and this is just one way of looking at the data that you produced when you run CMAQ. The next plot is an AMET model evaluation, or AMET temperature plot for 3 different domains. Again, this is using the metExample data sets for MCIP, WRF, and MPAS. And this is the reason I'm showing this again is to say you wanted to do a time series plot comparison between MCIP, WRF, and MPAS. If you don't constrict the geographic region to use the same data for all three models to the same geographic area, the time series plots will look very different. And so the best way that I've found using the website is to actually draw a latitude, longitude box and specify this is approximately for the CONUS. So you're basically limiting your model observation paired data averaging to the same region for all 3 models, and then you get very similar temperature time series plots. And it looks something like this. So this plot shows WRF, MPAS, and MCIP in comparison to METAR. This is the observation data for temperature, and you can see they're in fairly good agreement. And then this is a spatial plot for the MCIP model. So on the left is the MCIP model output data, and on the right is the METAR temperature observation data. This is the temperature scale. And so you can see it's hot in the south, it's colder in the north. It really, by eye, it looks like that data is identical in most places, but I did find you can look at the model obs difference plots and see the sites where there is a difference between the predicted model concentrations and the observed concentrations. And so that's this site here. So when you're interacting using the interactive plots, you can click on them and see this type of data. So this was the latitude, longitude of that site, and the model observed, or no, isn't the model, the observed value for temperature at this station was 300 Kelvin. The model predicted value at this station was lower, and so there's a negative bias for this site. And so that's showed here in like -3 Kelvin. These again are the plots that are created here, and you can use these links for the next day or two to examine those plots. So what is the benefit of the AMET website on AWS compared to just installing AMET yourself on your own compute server at your organization? The main benefit is that a lot of the software is pre-installed and the data loading has already been done. And so you should be able to get started right away for these cases that we're providing to do analysis. So if you are a teacher and would like to teach a model evaluation, this would be a great way to get your students started at looking at model evaluation. So through the website, you create plots that are interactive and you can explore the data more than I think you can do. Yeah, you can also do that if you install the Apache website on your own compute server. But again, the work has been done to create the AMI, and then we can share it publicly. Will allow people to get started more quickly in using this tool. There are limits to using the AQS website in that some of the query options are limited. So how some of the plots are annotated, you can't control that so much through the website, but you can get into the code and make edits or changes. And then, of course, if you wanted to load your own model data projects, you would need to log into the virtual machine and upload that data and do the data loading into the database, and then you could use the website for that project as well. So all the underlying code is available on the virtual machine that you will have created from the AMI. The other disadvantage, I think, or maybe it's an advantage, but it does allow you to make selections that will not create plots. So if you try to match a network that doesn't contain the species that you've selected, if that network doesn't contain that species, the plot will fail right away. And that's good because it lets you know that you've made a selection through the website that isn't going to work. And so you have to look at your selections again and say, is the species that I'm interested in the network? And you may have to get into the virtual machine and do a query yourself to understand what observations each of the networks has to be able to match to the model data. So now I'm at the part of doing an interactive demo for you all for AMET-AQ. So let's see. I'm going to stop. Nope. Okay, so now we need to go to not this. So this is a web browser, and I have made all of the kind of the tabs that usually appear at the top of the web browser. I put them on the side, and then I've grouped the types of plots that I've created already under headings so that I know what those plots are for future reference. And so if you're going to be doing a lot of web-based analysis, you have to come up with a system where you can generate plots, look at them, and then maybe generate some other plots, and then go back and re-reference the plots that you've created earlier. So it's just going to be important to kind of come up with that type of system. So this is the model evaluation website, and I'm going to start by showing you that there are different databases. So this is the EQUATES database. This is the AMET database. There are also information, so tables, these are basically tables in MySQL, and these tables are required for these two databases. So we're going to choose the AMET database, and we're going to choose the aqExample project. So these are following the steps that I described in an earlier slide. And then we're going to select the observation network of AQS daily ozone. And these parentheses are really important. So this is what is available from that network, 1 hour and 8 hour max ozone. So in this species list, if I choose ozone, it will not work because that's not available in that network. You have to choose ozone 8 hour max. So we're going to choose ozone 8 hour max, and then we're going to limit the date range to what I know is in the database, which is just July. So we're July 1st, 2018 to July 31st, 2018. And then I'm going to scroll all the way to the bottom and choose a plot. So we're going to choose a spatial plot with animations. So we're going to go down to the spatial plot section and choose this version here. And then we're going to run this program. So this is going to take about 2 minutes. This is to give you a realistic sense of how long it takes to generate some of these plots. And again, I'll go over the importance of, creating these groupings of your tabs and labeling them so that you can see and reference back to previous plots that you've created. So these are all previous plots that I created when in preparing for this webinar. And I just encourage you to do that as well. So it'll just take another minute, I think, and we should see the results section after this, or we'll get an error message and we'll have to look at that. But the results section will provide links to the plots, and we'll click on those plots and view them. Okay, so these are the results of that R program that we selected to, and so it created a lot of plots: observations, models, diff, max diff, absolute, max diff, all kinds of metrics. I'm going to look at this difference plot with a slider, which means it's an animated plot. So I'm clicking on that plot, and then you can turn on and off different traces. I think the black, this one just has lat long values. So this is now showing only the AQS daily model observation pairs. So the difference between ozone measured by the model, or predicted by the model, and ozone measured. So these values are like a difference of 15 down to -15. And here we're going to play. So over the month of July, these are the model obs differences for each site. So when you're looking at a time series plot, you're looking at the average of all of these sites over time, or whatever selected region you've queried for. So if you only wanted to look at regions around the Great Lakes, then you could use the lat long to filter only a specific set of regions. So here, this is part of the plot interaction. We can create a box and highlight just these sites, and we can also pan. So we're going to use the pan, move it to the center, and I'm going to zoom in on that area. Here it is. So if this was our region of interest, we could then click on any of these stations or locations for the station. So this is showing that the network that we're using is AQS daily, the station ID, the lat long, and then the value of the difference between the model and the observations. So you can see it's green, it's like -7.8. Over here, it's purple, it's a negative bias of 19. Here, it's a positive bias So the model is over predicting what is being observed at the station location. So this is just one of the plot types that you can use or create an AMET to kind of query and understand the data that's available. Okay, I'm going to go to the next example, which is for the AMET model evaluation tool for meteorology. So this is a different website. Let's see if we can see the header. So it's querygen_met.php. And again, you select, if you look for the MET, there are no projects you can select for EQUATES. There's only the air quality data. But for AMET, we have 3 different projects that you could select: MCIP, MPAS, or WRF. And so for this example, I'm just going to select the metExample WRF. And I'm not going to limit the geographic region for this, but I am going to just select the METAR observation network, select the temperature variable, and go down, and we're going to choose the program interactive spatial plot. So this is again a spatial plot, and it's this one for multiple plots. So we're going to run this, and it's going to take about 2 minutes again. So this is not an animated plot. This is going to be a spatial plot that's averaged over, I think, but we'll have to see. So while we're bringing that up, I'm going to just show you the documentation. So on this link that's also provided, we have AWS or CMAQ on the cloud, but we also have a section. So after you've run CMAQ, then you would want to do the analysis. And this section here is describes how to do that. So it looks like that plot finished. Let's see, where was I here? Let's see what the results were. So that plot finished, and we have an observation HTML, a model HTML, and a diff HTML. So this is the difference between the model and the observations. Clicking on that. So this is that difference between the model and observation predictions, or not predictions, predictions from the model, observations, observed values from the network. And you can see this was the site that I was describing in a previous slide about there being a difference here, but most of these have very small differences. And so by eye, you can't really see a difference in the spatial plot for temperature predicted by WRF compared to the METAR data. But there are these sites, and if you query the original, so if we go back, this is the ops plot, and we could go again and look at the model plot, and you can see by eye, I can't tell that there's a whole lot of differences, but that's why we use these queries and these plots to look at the values that are calculated. So the other thing you can do with these types of plots is change the topography, the background map. So here, this kind of shows different regions. You could zoom in. Let's see. You may be able to zoom in. Yeah, so I'm just using my mouse to zoom into an area. And then you could query information about these sites. So here at this site, the observed value was 296. The model was 297. And the difference was somewhere in this gray region. Whereas this site, and if you knew something about these observation stations or what the emissions were near this station, or what, I'm not sure exactly what would cause a difference in temperature, but if you knew more about these sites, you may be able to inform yourself as to why you might expect to see a difference at that particular site. Okay, Let me go back to the AMET documentation. So as I said before, there are lots of plot types that I'm not going to go over, but I have sections for the aqExample database. These are the instructions again of how to create the selections needed to generate the plot. And these are the plot examples. So if you wanted to look at a density scatter plot, these would be the options that you would choose, the plot type that you would choose to see it. This is what the results would look like, and this is what the plot would look like. If you wanted to look at box plots, this is an interactive set of box plots. So for every day in July, this is one of these is the model, and one of these is I can't really see. So the AQS daily is the observed values, and the aqExample is the model data. So you can use this sidebar over here to navigate. So this is the plots that you can generate using aqExample. Then there's instructions on how to load your own data into the database. How we loaded EPA's EQUATES data, we used a dump file basically from their AMET installation, obtained that and imported it into ours, and then how to create different types of plots using that EQUATES data set. So this is a summary panel plot, lots of different types of plots that I'm not going to go over here, but you can go through this tutorial and create these plots using the virtual machine that you'll create from the AMI. So basically, if a plot worked, if I was able to get a plot to work, I tried to document it in this documentation. There are some plots that I either couldn't get working, or there needs to be a fix at the developer end, and those are not included in the documentation, of course. But there's also a section on the how to create the meteorology plots using the AMET-Met website. So some of the same things that we have in the webinar descriptions, and information about how to create the plots. This is for those statistics plots. Let's see, what density scatter plot for temperature here. A histogram plot for T2 meter temperature. Lots of cool things to explore. So even if you didn't want to generate a virtual machine, you may be able to learn some things just from the plot examples that we provide in this tutorial. Okay, let me go back to the presentation and just finish up, and then we'll open the floor for questions. So we've done the interactive demo. These are some practice examples that we'll be saving to a PDF. So for today and tomorrow, if you want to look at these plots and interact with them, you can click on these links that'll be in the PDF. And I gave some things to think about, like what you could do when you're there. Like, can you understand a difference? Is there an observed difference in the plots if you're looking at data that's typically located at urban sites versus rural sites? Lots of things to think about and answer using this practice example guide. And then there's another set for the AMET-Met website if you'd like to look at any of these plots interactively. So I think Sedona is going to drop a PDF with these 2 slides in the chat, and you could look at those and do your own exploration of these plots. So this is the example that I was talking about for when you're querying using the website. This is something I ran into. I was querying, and I was trying to just restrict my query to the United States. But some of the data is labeled as being a site that should be a state in the US. This site specifically in Oman is labeled as in Indiana. And so when I did the query for only the US states, I got some data in Europe. I got all the sites in Manitoba, Canada, because this state was labeled as Minnesota. So it's important when you do a query and look at whatever plots that you've generated, that you understand what data is being used from that query. It's just a caution. So rather than use the states to try to restrict a geographic region, I would, in this case, use a lat-long box. And that way you're sure to get the sites of interest. For additional resources, we have the documentation on the cloud that I went over. This is a link to the modeling guidance from the EPA, and this guidance has some really great information that's relevant to AMET, including a definition of all the statistical metrics. It contains information about how to do ozone model performance analysis and PM2.5 model performance analysis. And it has a great description of all the ambient measurement networks. And so I would start here if you would like to dive deep into AMET. There are also all these wonderful model evaluation papers to read as well. So I just want to thank everyone for participating in this webinar, and especially to EPA who provided the funding. I'd like to recognize my co-worker Manish Soni, and also folks at EPA, Fahim Sidi and Wyatt Apple, for helping me install the AMET website on AWS and resolve issues with that installation. And then we also had another coworker, Jaicheng Yang, and Manish did a local installation of on a UNC virtual machine, following the instructions that I had in the tutorial. So there is a developer section of that tutorial. If you wanted to try to follow those instructions and install AMET on a virtual machine of your own, you could go through that as well. And for any of these tutorials, I would really appreciate feedback. So if there's a problem that you've run into, let me know, and I will try to resolve that issue and fix the documentation. I'd also like to recognize the great UNC EPA operations team for CMAQ and AMET support, including Kristen Foley, Christian, Fahim, Daewin, David, Sergey, Sarah, Rohit, Jeff, Havala, Chris Messinas, Wyatt Apple, and Robert Gilliam. And then our team, myself, Manish, Sedona, and Sarah. For technical assistance for AWS, we've received some help from Timothy Brown from AWS Services, and we want to also recognize AWS for the Open Data Program, which allows us to host these really large CMAS data on CMAS Data Warehouse. And I'd like to also thank all of you, the CMAS community, for participating, for using AMET, and for providing feedback for all the tools that we help support on the user forum, and that'll help us improve all of these models and tools. I think that's it. I'll go back, turn on my video.
Thank you so much, Liz. That was great. I do see we have 3 questions already in the chat, and I'm sure we'll have some more come in as well. Or if anyone has one they want to say out loud, you can raise your hand. But just to start out with Scott Bell's question, is it possible to share the web interface code to run on-prem? Global cases are pricey on AWS, price for load spike management, not multi-day compute.
Yes, the code is available on the develop branch on the AMET GitHub site. And so I think that I had to make some modifications. So I think that the paths specific to EPA server are not generic. And so if you try to use the PHP website code, you would need to go in and point to local paths on your local virtual machine or your on-prem machine. So it will take some edits. And I think I described some of that in the developer guide, but I also have the edits that we made for this AWS installation that may be of interest in a branch on my GitHub clone of AMET. So I'm happy to share that with you.
All right, and it looks like Wyatt jumped in with an answer to the second question that came in on the chat. Another one from Rachel. Are there any plans to host a suite of EQUATES AMET plots on a web page permanently?
So the EQUATES AMET plots that I have on the tutorial are permanent. They, other than the fact that I make edits to them from time to time, but those are available, and I will try to add any of these plots that I've put in the presentation back into the tutorial to make sure it's a complete set. But yes, those are there permanently as long as we have this read the docs access, yes. And I can share a link for that. Or Manish, could you share a link? Thank you, Kristen, for the accolades. And Christian. And thanks to Wyatt for answering questions. So I'm happy to have the developers or any of the folks from EPA who would like to make comments or, provide insight to join us in this conversation. If you'd like. I think if you just raise your hand, then Sedona can unmute your mic. And this presentation will be sent out by Brian sometime after this webinar. So the full presentation will be available, as well as, I think, the recording. Is that correct? Yeah.
That's right. Yeah.
Hey, Wyatt.
Hey, can you hear me?
Yes.
Okay, great. Yeah, Liz, great job. I think that was really informative. I don't see a lot of questions. I don't see a ton of questions. That's maybe a good thing. I'll just say, you mentioned one of the plots took like 40 some odd minutes to complete. My guess is maybe that was with hourly data. Like anything, once you get into plotting stuff with hourly and doing a lot of it, it can really slow things down. There's just no way to get around it with the database, really. But I think overall things seem to be plotting pretty quickly at the level that I would think they would. So I just mentioned that as a precaution to people who may get into doing this. If you start working with hourly data and try to pull a lot in, it can get a little slow to do that, just based on the number of data points that are trying to be managed.
Thank you, Wyatt.
Yeah. And I know you didn't show a lot of the all the different options on there, Liz. I just mentioned that there is a fair bit of configurability to plotting ranges and things like that. So, for those who might be curious if there's a way to further tailor plots, there are a number of options on there that kind of let you tailor things to some degree to what you might want to see. But I know that would have taken way too long to get into all that. Yeah.
Yep.
Thank you, Wyatt.
Yeah, thank you.
No other questions coming in. So if you have one last minute question, you're welcome to send it over. But otherwise, I'll pass it back to Saurav to just give a couple brief announcements from the CMAS Center overall. And thank you again, Liz.
You're welcome.
Thank you, Liz, and thank you, Wyatt, for jumping in. That was fantastic, Liz. Wonderful demo and wonderful background to the AMET-Web and how people can use this. One specific addition I want to add on top of what Liz went through is to remind people that this is a capability that will perhaps allow people across different entities, different institutions, to share a specific modeling data set and then look at analysis interactively across some distance, okay, miles and hundreds of miles or more, right? The key is to have collaborative work, and I think this will be one way to have collaborative work where people can look at multiple aspects of how the model performs and be interactive with what we're doing. So that's just a reminder I want to make on top of what Liz went through. With that, I just have one announcement. Reminder, we are on for the 25th anniversary CMAS conference that's coming up in October. The dates are set, 19th to 21st. The call for abstracts went out earlier this month on May 1st, I believe. So we invite members of the community to start submitting abstracts and make your travel plans to come to Chapel Hill. We should have a party. It's a 3-day event as always, October 19th to 21st, and there should be a lot of very interesting talks, both from the EPA and from some other keynote speakers outside the EPA. We look forward to a great event and hope to see all of you in Chapel Hill in October.
Thanks, everyone.